Hi everyone, and welcome to today's lesson on gravitational potential energy. Before we get started, I'd like you to do the usual. Go away, find a quiet space, get yourself pen, paper and a calculator for today's lesson. And once you're settled and ready to go, write down today's LO and start doing the retrieval questions. So you will need to pause the video now and complete all that. Okay, so let's go through the answers. So these are all based on our previous lesson on kinetic energy and elastic potential energy. So hopefully you're able to get 5 out of 5 for these. So what is kinetic energy? Kinetic energy is the energy stored in a moving object. What's the equation for this? So it's 0.5 multiplied by mass multiplied by velocity squared, or if you wrote it in the symbol form, EK is equal to 0.5 mv squared. For elastic potential energy, it is a stretched spring is a store of elastic potential energy, and your equation for it is 0.5 times K times E squared. Don't forget that K is spring constant and E is extension. The last question was to do a calculation, so it asked you to calculate the kinetic energy store of a ball with a mass of 0.5 kg moving with a speed of 10 meters per second. Hopefully you got this one. You just had to use your equation, substitute in 0.5 for your mass, 10 for your velocity, and you should have got 25 joules. So if you need to, pause the video now, mark your work. Hopefully you got 5 out of 5. Alright, so today what we're looking at is gravitational potential energy. The specification asks us that we understand and we know how to use the equation for this, and you can pause the video now if you want to read that there. What you're going to be looking at today is how to describe gravitational potential energy, how to calculate it, and we're also going to investigate the transfer of energy from gravitational potential energy to kinetic energy, because it's quite a popular question that comes up quite often. Alright, so first thing you're going to write down today is your definition. So a green box means it's a definition, it's important, we need to learn it off. So my definition for gravitational potential energy, it is the energy stored in an object due to its position above the Earth's surface. So all that means is that my gravitational potential energy is dependent on how far away I am from the surface of the Earth. Okay, gravity we know is due to the Earth pulling us down. It's that force of gravity acting on an object. So when we're talking about our gravitational potential energy, we're talking about that. Alright, so hopefully you've wrote that down now, and I want you to think about this question. What is the value of gravity on Earth? So you might have come across it when you were in year 7, 8 or 9. You would have talked about it a little bit, you would have learned what gravity is, but what is the actual value? What number do we assign to that? So hopefully most of you knew that we assign the number 10, so it's 10 newtons, and hopefully you knew that. So how can we actually lift a ball onto a shelf, and what kind of energy do we use? So this is just the example we're going to talk through to understand gravitational potential energy. So if you imagine you've got a shelf and you've got a football or a basketball, and you want to put that ball up on your shelf. To start with, your ball is just sitting on the ground. It has no gravitational potential energy, it's got nowhere to go, it's just sitting there. It's as close to the ground as it can be. As you lift that ball though, you're going to be using kinetic energy. You're going to be moving that ball upwards to get it up onto the shelf. So we will be using, us the people lifting the ball will be using kinetic energy to move it. The ball now has a store of gravitational potential energy. We can see that the ball is now no longer touching the ground. It's no longer touching the surface of the Earth. So therefore, it has got gravitational potential energy because it's been moved away from the surface of the Earth. So because this is the highest point that the ball goes, we say that it now has its maximum gravitational potential energy reached. But what happens if that ball falls off? So if the ball falls off the shelf, as it falls, that gravitational potential energy is going to be converted back to kinetic energy. Because don't forget, kinetic energy is moving energy, okay? It means movement. So if the ball is moving to get back to the ground, all that energy that you had stored up on the shelf has now changed back into kinetic energy. Once the ball hits the floor, the gravitational potential energy is going to have turned back into zero, okay? Because it's now back touching the surface of the ground again. Alright, so hopefully that gives you an idea of what gravitational potential energy is. It is just the energy that we talk about when we're talking about how far an object is away from the surface of the Earth. So we're going to look at how we actually calculate that. So again, this is a green box. It's something we need to learn off by heart. We're not given this equation in the exam, so you do need to pause the video now and write this down. So gravitational potential energy is mass times gravitational field strength times height. So gravitational potential energy, we use the symbol EP for potential energy, and we measure it in joules like we have measured our kinetic and our elastic potential energy already. Mass we know is measured in kilograms, and it's got the symbol M. Gravitational field strength is newtons per kilogram, and that is measured, that has the symbol G. And then finally height is measured in meters, and that has the symbol H. So for your gravitational potential energy is mgh, mass times gravitational field strength times height. If we're on Earth, we can usually assume that gravitational field strength is 10 newtons per kg. So if we're on the surface of the Earth, it slightly changes depending on how far away we are from the core of the Earth, but if they do not tell you in the exam what the gravitational field strength is, you are allowed to assume that it is 10 newtons per kg. So it might be an idea to write down that little last box there as well. Okay, so again, I'm just putting this up there for anyone that likes to use the equation triangle. You do need to know how to rearrange this equation. You need to show all your workings out. If there's any conversions, you need to do the conversions, and then you need to substitute correctly. So it might be worth just going over that again, rearranging the equation to find gravity on its own, to find mass, and to find height on its own. If you do that, you should have come up with the following three equations. So like I said, you need to learn this equation off by heart, and then you can see here, this is my triangle. Energy is on top, divided by mass times gravity times height. So if I wanted to find the mass is equal, so I would cover over mass. Mass is equal to energy divided by gravity times height. If I wanted to find the gravitational field strength, cover over that, and I'm left with energy divided by mass times height. And if I want to find the height, lastly, cover over height, and I'm left with energy divided by mass times gravitational field strength. So you do need to be able to rearrange the equation, but you need to know it off by heart. So let's look at an example. A crane lifts 75 kg mass, a height of 8 meters. Calculate the gravitational potential energy gained by the mass. In this question, however, instead of assuming that my gravitational field strength is 10, I've actually been told that it's 9.8. So it is important there that I don't write in 10 for gravitational field strength, but I write in 9.8. So I've got my equation, and I'm going to just substitute in 75 is my mass, 9.8 is my gravitational field strength, and 8 is my height. Pop all of that into the calculator, and I should get energy is equal to 5,880 joules. Right, so pause the video and try and do this question yourself. Okay, so a ball with a mass of 500 grams is lifted onto a shelf which is 1.5 meter above the ground. Calculate the gravitational potential energy gained by the ball, where gravity is 9.8. Again, we've been given the gravitational field strength of 9.8, so we don't say 10. But I hope you realized that actually we don't use grams for mass, we use kg, so you would have needed to convert that 500 grams into 0.5 kg. So then when we substitute all of that into our equation and pop it in the calculator, we should get energy is equal to 7.35 joules. Again, take an opportunity to pause the video and try this question. Alright, so again, we've got 5,000 by 10 because this time we're told to assume that the gravitational field strength is 10 by 10,000 is its height, because again, don't forget, we measure height in meters, not kilometers, and we know that k is multiplied by 1,000, so my height is actually not 10 but 10,000, and that gives me 500 million joules. That's quite a large number. We know in physics we don't like large numbers with loads of zeros, so we're going to convert that into megajoules, and megajoules just means that I've multiplied it by 1,000 by 100,000. Okay, here's another question for you to try. Again, just pause the video, give yourself a chance. Okay, so an orange with a mass of 250 grams falls 2.5 meters from a branch to the ground. How much gravitational potential energy will the orange have lost when it hits the ground? Assume a value of 10 newtons per kg for gravity. So again, we need to remember that grams needs to be converted into kilograms, which is 0.25, and then we can pop it into the calculator and we should get 6.25 joules. So now you should be able to calculate gravitational potential energy, and lastly we're just going to look at the energy transfer between the system. So imagine a tennis ball with a mass of 60 grams dropped from a height of 50 centimeters. Again, all we need to do is pop it into my equation, and I should calculate that the energy produced in this is 0.3 joules. There's no kinetic energy because it's not moving, it's in my hand, so the total energy in the system is 0.3 joules. Once I drop that ball, however, I can say that all that potential energy has converted into gravitational potential energy, has converted into kinetic energy. We know if we talk about a closed system that energy doesn't go anywhere, it's just 100% conversion. So therefore I can say that all of that GPE is converted into kinetic energy. So now my GPE is 0 because my ball is on the ground, and my kinetic energy is 0.3. Alright, so what happens to kinetic energy and potential energy of a roller coaster? So I want you to pause the video now and have a think about what does happen. Alright, so as the roller coaster loses height, its store of gravitational potential energy is basically just being turned into kinetic energy. So for all the gravitational potential energy we lose, we're gaining kinetic energy. So this equation is only true if I have no air resistance and no friction. In reality, we know that's not the truth, but for this example, we're going to pretend it is. So this is just an example of what happens. I start out with a mass of 1,000 kg, gravity is 10 newtons per kg, and at the minute I can calculate what my kinetic energy is. So I'd like you to try that. As I go up and up and up, all of that kinetic energy to lift me up to the top is being transferred into gravitational potential energy. Once I reach the highest point, that means I'm at my maximum gravitational potential energy, and then I start to go down. Again, that starts to convert back into kinetic energy. So all we've done is we've gone from kinetic energy converts into gravitational potential energy. I've zero kinetic energy, back into kinetic energy, and back again. So you go kinetic, gravitational, kinetic, gravitational, and they're basically just going up and down like your roller coaster. Hopefully now you're able to answer all three of these success criteria.